All right, we are going to read section 2. This is chapter 1, section 2, the geographer's tools. So follow my mouse as I'm going through things here. Before we read, it's always good to do a walk through the section. This is not fiction where you don't want to know what's coming. We always want to get our mind wrapped around what we're reading and what we're doing. So there's a good little prepare to read section here. In this section, you will find out how maps and globes show information about Earth's surface. You'll see how map makers show Earth's round surface on flat maps, and you will learn how to read maps. Okay. We won't be targeting a reading skill. Your teacher may have you take notes. I am not going to have them do that. Your key terms, you have the word scale, distortion, geographic information system, which is usually just abbreviated GIS, projections, compass rose, and key. So you will be adding all those words to your key term slideshow. Okay, the first part of the section is about globes and maps. Globes and their weaknesses, maps and mapping, aerial photographs and satellite images, and then the GIS. Okay, you can see a satellite image of North and South America. Okay, so that's the beginning of your reading. Then we'll be talking about getting it all on the map. And you can see at the bottom some of the different types of maps. So you have your Mercator map, and we have our Robinson projection, which is this section, equal area projection, which looks like this, and there are other projections too. You can't take a round object, you can't take 3D and put it on 2D accurately. Okay, then we're going to talk about reading maps. Here's a physical map of China. You can see a map over here of Georgia highways, which I know you're all can't wait to learn about. But we're using this mainly to figure out the parts of a map, the key and things like that. And then that's the end of your reading, just talking about maps of a different scale and how important scale is for that. And then you'll see your section 2 assessment with some questions there. And that's the end of chapter 1. Chapter 1's only 2 sections. Okay, so I'm going to read. I want you to read along with me as we go here. There will be questions mixed in. Do your best to follow along. Globes and maps. As people explored Earth, they collected information about the shapes and sizes of islands, continents, and bodies of water. Map makers wanted to present this information accurately. Globes and their weaknesses. The best way was to put the information on a globe, or a model with the same round shape as Earth itself. By using an accurate shape for Earth, map makers could show the continents and the oceans of Earth much as they really are. The only difference would be the scale or relative size. But there's a problem with globes. Try making a globe large enough to show the streets in your town. The globe might have to be larger than your school building. Imagine putting a globe that big in your pocket every morning. A globe just cannot be complete enough to be useful for finding directions and at the same time small enough to be convenient for everyday use. So that's why we use maps, not globes. Maps and mapping. People therefore use flat maps. Flat maps, however, present another problem. Earth is round. A map is flat. Can you flatten an orange peel without stretching or tearing it? There will be sections that are stretched out or bent out of shape. The same thing happens when map makers create flat maps. It is impossible to show Earth on a flat surface without some distortion, which means loss of accuracy. Something will look too large, too small, or out of place. Map makers have found ways to limit distortion of shape, size, distance, and direction. Map makers rely on ground surveys, or measurements made on the ground, to make maps. They also use aerial photographs and satellite images. More and more these days we use those satellite images. Aerial photographs and satellite images. Aerial photographs are photographs of Earth's surface taken from the air. Satellite images are pictures of Earth's surface taken from a satellite in orbit. Both types of image are valuable sources of information for map makers because they provide current information about Earth's surface in great detail. But they are not useful for finding objects that are hidden, such as underground transit lines, or features such as streams that may be covered by vegetation. Also, like any map, flat aerial photographs and satellite images give a distorted view of Earth's surface. So I know most of you have been on Google Maps before, or Google Earth, and you've zoomed in on Yorktown. When you do that, it's really hard to see the White River. Even though it's a big river, the vegetation hides it from that map above. Okay, next, Geographic Information Systems. A Geographic Information System, or GIS, is a computer-based system that links information to locations. A GIS is useful not only to geographers but also to governments and businesses. A GIS connects information with places. For example, if a business needs to decide where to open an office, it can use a GIS to choose a location where it will reach most customers. Military planners may use a GIS to improve their knowledge of the places where troops will operate. A GIS also may be used to produce maps. Okay, so over here we see a satellite image of North and South America. It's kind of hard to see in black and white, but you can see North America here under the clouds and South America down here. Okay, moving on to the next section about getting it all on the map when we're talking about the whole globe, not just a local map. In 1569, a mapmaker named Gerardus Mercator created a flat map to help sailors navigate or plan journeys around the globe. To make his map flat and to keep his grid rectangular, Mercator expanded the area between lines of longitude near the poles. Mercator's maps was very useful to sailors because it showed directions accurately. Even though sizes and distances were distorted, more than 400 years later, nearly all the seagoing navigators still use Mercator projection, or a method of mapping Earth on a flat surface. Okay, that's important to know. If you're in the sea, Mercator's map tends to be the best, the square one like this. Even though it makes Africa look huge, it's still the best when going by sea. Oh, one other thing while I'm on it. Don't think that the west side of the map and the east side of the map are far apart. That's a common mistake. Over here where my mouse is super close to over here where my mouse is. Where Alaska is, look how close it is to Russia here. Super close. Mercator maps make areas near the poles look bigger than they are. This is because on a globe, the lines of longitude meet at the poles. To keep lines of longitude straight up and down, Mercator had to stretch the spaces between them north and south of the equator. Land near the equator was about the right size, but land areas near the poles become much larger. Because of this, for example, on Mercator's map, Greenland looks bigger than South America. Look up here at Greenland. Here's South America. It's a distortion. Greenland is actually only about 1/8 as big as South America. Geographers call a Mercator projection a conformal map. It shows correct shapes, but not true distances or sizes. What other areas besides Greenland do you think might look larger than they should be? That's right, Antarctica. Looks huge down here. Okay, and so this kind of shows down here how the Mercator map works, how they took it and stretched it out. So that as the pieces went up, they had to stretch them together. Okay, next, let's look at equal area projection maps. That's like this one over here. An equal area map shows the correct size of land masses. These are all correct. But their shapes are altered. Lines that would be straight on Earth may be forced into curves to fit on the map's flat surface. Okay. Next, the Robinson projection. This projection is named for its designer, Arthur Robinson. Today, many geographers believe that the Robinson projection is the best world map available. It is used for most of the world maps in this book. This projection shows most distances, sizes, and shapes quite accurately. However, even a Robinson projection has distortions, especially in areas around the edges of the map. Okay, so down here's the Robinson one. It's the most used, except by seafarers. Other projections. There are many other types of projections besides the one shown here. Some are useful for showing small areas, but not for showing the whole world. Others are good for specific purposes, such as planning a plane's flight route. Okay, so there you have an overview of the three main types. The Mercator map, like this, all squares. The equal area map, like this, and then Robinson's projection, the most used. Okay, next let's talk about reading maps. Look at the map shown on these two pages. One is a physical map of the country of China. The other is a highway map of the state of Georgia. These maps cover completely different areas and show different kinds of information. Despite their differences, both maps have all of the basic parts that you will find on most maps. Knowing how to use these maps will help you to read and understand any kind of map. Okay, so let's look at this China physical one first. Okay, get your bearings. So up here's Russia. Over here's the Pacific Ocean. All right. Oh, right here, the locator globe. Right here you can see where China is. Maps may include a locator globe that shows on a globe the location of the map. Here's a title up here. Most maps have a title near the top of the map. The title generally tells you the type of information and area covered on the map. And you've been dealing with longitude and latitude in your bell work. Hopefully you're getting pretty good at that. Over here's the compass rose. A map's compass rose shows direction. North is usually, but not always, at the top. Here we have the scale bar. This is super important. The scale bar shows how distances on the map compare to actual distances on the ground. So you had this in your week 1 bell work. And it told you to measure things. That doesn't make sense when you can enlarge and make smaller. But 500 miles, you can see, is about the distance from where it says South China Sea to where it says East China Sea. Just the words, no matter how much I distort that. China, physical. This map shows the main physical features of China. Okay. Over here's the key. A map's key identifies all the symbols and coloring used on the map. Now this one is in black and white, so it's hard to see, but it shows you the elevation, how high it is compared to sea level. The different colors you can kind of see. So you can see the highest area is the Himalayas. If you know anything about the Himalayan mountains. Okay. So there we have a physical map. Over here we're going to have a highway map. Let's read the parts of the map and then look at the highway map. Both maps on these pages have what geographers call a compass rose, a diagram of a compass showing direction. If you want to find directions such as north, south, east, or west, just look for the map's compass rose. Both maps also have a scale bar. The scale bar shows how distances on the map compare to actual distances on the land. Scales vary depending on the map. If you compare the scale bar on the map of China to the bar on the map of Georgia, you will see that the map of China covers much greater distances on the ground, even though the map is not much bigger. So over here, that's 500 miles. And up here, that's 100 miles. Third paragraph. On any map, the key or legend is part of the map that explains the symbols and shading on the map. For example, the key on the highway map of Georgia shows the colored lines that stand for different kinds of highways, while some maps use symbols, or other maps, like the physical map of China, use coloring to present information. The key shows which colors stand for which elevations. Okay, so the Georgia highway map up here. I'm reading over here. Notice that this map of Georgia has the same basic parts as the physical map of China, but it covers different information. This key talks about the interstate highways. We call them I, like I-69. The U.S. routes, the state border, the state capital, and other cities. Okay, so you can see the state border. You can see the interstate systems around Atlanta. Atlanta's a mess traffic-wise. If you've ever been there, these highways get clogged big time. The state capital, which is Atlanta. Other major cities, Athens, Rome. Athens is where Georgia, the Bulldogs play, I think. Mason, Columbus, Valdosta, all the major cities in Georgia. All right, it doesn't have Augusta. If you're a golfer, Augusta National is near Atlanta, but it's not a major city. All right, last bit of reading. We're not going to do the Section 2 assessment right now. Maps of different scale. On the scale bar for the map of Greater London, so the city of London, London, England, a mile covers a small space. This map has a small scale. It gives a general picture of a large area. Maps with a larger scale, such as the map of central London, show more detail and are useful for finding landmarks. So if you've ever been to London, I haven't, I'd love to go. You've got the bigger map and then a zoomed in smaller map where you can see some famous things like the British Museum, or Buckingham Palace, their House of Parliament. And so these zoom in, like within a mile, you can walk to a lot of things that are really famous here. Where you're not going to walk from Watford all the way over to Dartford, since that covers a much bigger area. All right, there you have it.